Let's go ahead and look at a couple of graphs of natural base functions. So again, keep in mind that this is our function that we are starting from, and we will identify an a value and an r value. So for this first one, we have y is equal to 3e raised to the x power. And so our a value is a 3. And our r value is, well, it must be a 1 because there isn't any number in front of x, so r is a 1. Remember that for these, we are looking for either a positive or a negative r value. So an r of 1 is positive, which means growth. We can see by looking at the graph that we definitely have a growth function. And let's go ahead and notice a couple of points. Remember that previously we were picking out our y-intercept, which was located at 0, and our a value. And since our a value is 3, our y-intercept is at 0, 3, just like it was for our regular exponential function. At a value of 1, so when x is a 1, we have e raised to the r power. Well, in this case, it's e raised to the first power, but then we have to take that and multiply it by our a value. Our a value isn't 1, it's a 3. And so at 1, I see that I'm intersecting right up here at the very top of the graph, and that point is actually going to be at 1, 8.15 about. And 8.15 is 3 times e raised to the first power. So remember, when x is 1, we just have a plain e multiplied by 3. Our asymptote, we are still approaching but not crossing the x-axis, so our asymptote is at y equals 0, just like our exponential functions last time. Domain, all real numbers. We can see that we are headed very distinctly to the left. We are heading slightly to the right as we go up. And our range based on our asymptote is that y is greater than 0. Let's look at our next one. And right off the bat, you should notice that we have not just our regular exponential function, but we have a +1 tacked on the end. Guess what that does? It does the exact thing that a +1 tacked on the end of any other function that we've discussed this year does. A +1 means that we have translated up by 1. So we've taken our entire graph and shifted it up by 1. So that means that now we don't have an asymptote at a y value of 0, we're going to have an asymptote at a y value of 1. So everything we've talked about up to this point is going to get but there's a +1 added onto it. Let's identify a, and that's going to be a 1 because there is not a number here in front of e, so it's the implied 1. The r value is negative 0.5. And since that's negative, it indicates decay. And we can see that decay here on our graph. We are definitely heading down on our graph. Let's go ahead and identify some points. We have a y-intercept at 0, 2. Now that is different than normal. We've normally had our a value as our intercept. However, now remember we have shifted everything up by 1. It would have been here, except that because of this +1 tacked on the end, it has shifted up by 1. So this too is a plus the translation up by 1. Over here at a value of 1, we can see that we're above 1, maybe a little above 1.5. And in fact, this point is at 1, 1.607. How do I know that? because when I plug in a 1 here, that means that I have e raised to the negative 0.5 power. And when you do e raised to the negative 0.5 power, you get 0.607. However, we also have to say plus 1. So this number right here is e to the negative 0.5 power plus 1. Our domain hasn't changed just because we shifted our graph up. Domain is still all real numbers, but range has changed now. Because our asymptote is at 1, our y value is now at greater than 1 for our range.